Okay, so here we're faced with a problem where we have a cup of coffee that's being brewed, and then it's going to cool to an acceptable temperature to drink. I'm going to go ahead and read the problem to you, and then I'm going to go ahead and type the data into the table. I don't think there's going to be an issue with you not having the problem in front of you, since you're going to be able to see the data on the screen. It says, the best temperature to brew coffee is between 195 and 205 degrees Fahrenheit. I don't know if there's any validity to that. I'm not a coffee drinker. It says coffee is cool enough to drink at around 185 degrees Fahrenheit. The table shows the temperature readings from a sample cup of coffee. How long does it take for the coffee to be cool enough to drink, assuming that the room temperature is about 68 degrees Fahrenheit? Use an exponential model to answer the question. Okay, so I'm going to go ahead and show you how to enter this data into the calculator. The first thing you're going to do is go to Stat, and then you're going to choose that first choice for Edit, and that should bring you to your lists. The times in the table, starting at 0, go every 5 minutes. So I'm going to go ahead and enter those in quickly. 0, 5, 10, 15, 20, 25, and 30. So I've got my times entered in. Moving over to list 2. List 2 is the temperature that was recorded at that time. The first one here was 203. The next one was 177. The next one is 153. And then at 15 minutes, we're looking at 137 degrees, 121 degrees, and then 111 degrees, and finally 104 degrees. Now, normally I could just go ahead and run exponential regression right here. However, that assumes that the calculator, when it does that, it assumes that the asymptote line is going to be y equals 0. So it's going to come all the way down, try to make a function that goes all the way down to 0. The fact that the room temperature here was 68 degrees, this cup of coffee is not going to cool down to anything less than room temperature. So what we're actually going to do is we're going to adjust these temperatures for the time being in list 3 by subtracting 68 degrees from each one of them. So that would make this first one, I'm going to move over here, that would make this first one 135 degrees. The next one 109 degrees. The next one would be then 85 degrees. $69 degrees. $53 degrees. $43 degrees. And 36 degrees. Okay. So now that we have those in, now we're ready to go ahead and run the exponential regression on this. So we will go back to Stat. We will move over to Calculate, and we will go down until we see Exponential Regression, which is choice 0. We'll select that. Our X list, we want that to be list 1. Our Y list here, we're actually going to go down here, clear that out, and make that list 3. So over here, list 3 is down here on the 3 key, so I can do second, and that to get list 3. And then I can move down to Calculate. And there I have my values for A and B, and I can write my function. Okay, so you saw a second ago on the graphing calculator, I was able to compute the values for A and B for this exponential function. So the value of A representing the initial value, which you can see is actually nowhere near what the initial temperature was here. for this, but it should be pretty close to our adjusted temperature after we had subtracted the 68 degrees. And here's my value of B for my decay factor. It is cooling down, so you can see that it is decaying. What we need to do to actually make this representative of the situation is go ahead and add on the 68 degrees at the end here that we had subtracted off whenever we used the calculator to create this function. Again, we did that on the calculator because the calculator was going to create an exponential model that went all the way down to 0 regardless. We didn't want it to do that. It wouldn't actually have the shape of this cooling curve. So we adjusted those numbers so that it would go ahead and fit the shape down to 0, and now that we've got that shape, we're going to move it back up to where it needs to be to actually represent the temperatures that we have here. Okay, so we just wrote our function, and now we want to figure out about how long it will take this coffee to become drinkable. So we're going to go ahead and go to our y equals screen here on our calculator. We're going to go ahead and graph our function, which is on the board behind me there. We'll have to look at it for reference. 134.5 times 0.956 to the x power, and then increased by 68. So that was my function. I can go ahead and graph that function. I'm not going to see a whole lot because I don't have my window set to something reasonable. So I'll go back here to window. My x minimum, I'm going to go ahead and just set that at 0. My x maximum, my times I think went up to 30 minutes or so. So I'll go ahead and clear that out and set that at 35 just to be, change the wrong one. That one was 0. My x maximum, we'll go ahead and clear that out, set that at 35. My y minimum, I'll just go ahead and leave that at 0, even though it's not going to get down to 0. My y maximum, it started off at like 203 degrees. I'll go ahead and set it just at 210, like that. And we'll go back to the graph and see what it looks like. So there's my cooling curve for this. And I want to know when this reaches a drinkable temperature of 185 degrees. So I'll just go ahead and graph 185 as well. And then I should go back and see a horizontal line representing 185 degrees right there. And I want to know where that intersection is. So I will go to second and then the trace button up here to get to the calculate menu. I will choose intersect. It's going to ask me first curve. Notice it's on the blue curve. I'll just go ahead and hit enter. It jumps to the other one. I'm going to hit enter. It asks me to guess. I don't feel like it. I'll just hit enter a third time. And it jumps to that intersection point right there. So the X right there represents the time. So that's about 3.09, about 3.1 or really close to 3 minutes that it's going to take this thing to reach the acceptable drinking temperature of 185 degrees. And that kind of answers the question then that they're after.